Hey everyone, welcome. I see quite a lot of people already joined, that's awesome. I can hear myself back. Just say if the sound is not right or it's too loud. Hey Krish, hey Chinta, Emma, Shubham. So I'm just going to give a bit of time because we're going to take it a bit slower today. A bit basic PCB design, nothing as hectic as what we did with the drone. So the drone is done. I thought Kerry said this is charged, but apparently not. My earphones just died. So how are you guys doing? So I'm going to make a simple LiPo battery charger. So we made the drone finished up last week, but then we didn't make a battery charger. So today I'm just gonna make a simple single cell battery charger. But take it, like I said, we'll take it slow. So I was thinking what to do, but I always want to do something that can be applicable to everyone and not just put on a light or something. So I think this is good, because I'll share the designs afterwards as well, right? So I'll be freely available to everyone. Now there is sound, Gary. I was listening to music. But anyway, doesn't matter. So I don't know what you guys think. If that is something you guys want to do. It seems the chat's working for both Twitch and YouTube. Can everyone hear me fine? Let me just... and they're broken. Or you just didn't charge it.
Powering on, mic off.
We'll see. I'll just give you about 5 more minutes and then we can start. So you guys happy with the single cell battery charger? Very simple, one IC. It's on now. So I think we can start with one cell and later maybe make it more complex, but today I just want to focus on how to take this idea, put it on the PCB. So that's the idea. And please guys, just ask as much as you want. We've got a lot of people here at different levels, so please, if you don't know anything, please just ask. I want to make these PCB designs again just for beginners, so get people into PCB designing. That's the goal. It's a bit delayed, eh? Shuba, I'm from South Africa. So I'm born and lived in South Africa for 27, 28 years, and now I'm currently living in the Netherlands. Where are you from? Hey Vikram, I'm going to use KiCad, so it's a nice free open source software, everyone can have it. We've got a YouTube video on how to install it if you want to install and do it with me. I know a lot of people use Eagle. I've not used Eagle to be honest with you, but it's a good software. So I'm going to try just go through the principles of designing, so you'll be able to do it here or Eagle or wherever. but we do have, so on our YouTube channel you can see Gary did a tutorial how to install KiCad and how to make a schematic and symbol and things like that. So if you guys want to install it, we can do this together, so I can wait if people out there want to install it. Nice. Where in India, or where from, Shosa? I'm just going to make this clear. I think quarter past we start, and then I think we gave people time to join. So like I said, if you guys want, just go to KiCad, download KiCad, the software, it's free. Then you can make a PCB with me. Wrong buttons. Banaras. Where's that? Where east, where south? Hey, Anad, yes, that is the goal. So I'm going to try take it slow, take it simple. If you have any questions while I go along, please just ask me. But yes, you don't need any knowledge about PCB design. I'm going to try to help you with that. So just stay tuned. I think we're going to start by quarter past. I'm just giving some people time to join us. What's your background, Anad? Electronics, or you just want to learn? Hey, happy Recom 007. So while we wait, so this is just what we did last time as a community, if it opens. But this was a bit too, yeah, we went too fast. So we made this.
Shutdown initiated.
Yeah. So we made this PCB for drones. This is actually not the latest one, I updated a bit. But that's how it looked. So this is what we're going to learn how to do. We're going to learn how to make PCBs. But not go straight here. We'll take it step by step. Yeah, so the drone controller we did last time. So we're not going to do that complicated stuff today. But it's basically just I'll show the schematic. It's basically just a microcontroller that controls some motor drivers, and then we've got a accelerometer to control it. So I'm going to order this board probably today or tomorrow. Just want to double check everything. I did send the files in our Discord, so if you want to just join our Discord, and you'll be able to chat to the members and everyone. So I just asked people to have a look at the design with me, and when we're all happy, we'll order it, and then we're going to program and test it. But that's free to available for everyone. But yeah, so we're only going to do one small section of a PCB design today. We're not going to do something like this. So I would really like everyone to be involved in this. But this is where we'll end. Is a specific question you want to know about it? So yeah, guys, you guys can join our Discord. There's a lot of people chatting there. So where's everyone mostly from? 4 more minutes and we're starting. Okay, just make sure everything works. So that was last project drone. So every Sunday will be live PCB day. We'll do step by steps. Okay, so I'm going to start now. So what we're going to do is, this software is called KiCad. This is software we use for PCB design, or I use. It's free, it's open source. That's why I like using it. So it's really a community software. So yeah, if you guys want to download it. You can follow tutorials. I can help you. And yes, so once you download this, you'll open the project folder. Let me just go from the start. So if I go here, KiCad, wherever it's installed in your PC, just open it. I will always open your last project, right? So our last project was a drone PCB. We'll just keep it in its memory. So we have file, new project. You can also do project from templates. So let's say you have Arduino or something. They can actually, you can make a PCB that you can fit on your Arduino, fit on your Pi. So the KiCad already made some templates. So if I want an expansion board for my Arduino Uno, I'll just open this. I'll just save it, test. And then if I open this, then you can see they already made a board outline for us that will fit on your Arduino. So I can just put my components here and this board will perfectly fit on my Arduino, which is quite nice, but it's not something we're going to do today. So file, new project, we're going to start a new project. I just make sure current projects. So we're going to build a battery charger. Guys, again, if I'm going too fast, if I'm speaking too fast, it's because I can sometimes speak too fast, I know that, and I can mumble. So if things are not clear, please just let me know. I'll happily repeat myself. I sometimes get ahead of myself. So we made a project. Great. So when you open a project in KiCad or any PCB project, PCB always consists of two parts, your schematic and your PCB. So your schematic is where you'll draw your components, how it will be connected, where, like you would do, how can I say, it'd be easy to explain, to show, but it's just, where are you going to connect all the wires, how are you going to connect the pins. So if you have a breadboard and you'll connect all your components, that's your schematic. And then your PCB is how it will look in real life. But your schematic is very important because all the connections you make in your schematic will be taken over to your PCB. So probably the most important part of this whole design is your schematic to make sure everything is fine. So you'll see schematic looks like this. So there's normally title. So let's just add that. I like working on A3, so you can go file, page settings, A3. And here we can say, so our date was today, hard revision 1. Letter small. Okay, I can try. Are you watching on your phone or not? So can't you read this title, like that says title, company? I'll try to zoom in. Hey Chinta, so I'm just going slowly through starting a PCB project. So I opened the KiCad, I opened a new project, and I'm just filling the details of the page, what we're going to build. So I'm going to start with a battery LiPo charger, just for single cell. So I'll show you guys how to do that. Great, so now you can see at the bottom here, we'll have battery charger, the date we started, hardware revision. So it's just nice to keep track because you'll make hardware revision updates things like that. Does it not run at 180p or not? Having trouble. As I do the circuit, I'll zoom in. Ah, that's why. Thanks, Gary. I keep forgetting. Every single stream, I do that. Hey, Pushali. Is this better, guys? Okay, I think in this screen I'll start over. It might be a bit better. Hey, Maverick. Guys, is this size better for you? Or do I need... okay, great. So I'm going to start over. So let's go KiCad. So file, new project. Like I mentioned, so you got project templates, alright? So here's actually quite cool where we can have expansion boards. So if I want to make a PCB that I can fit directly in my Raspberry Pi or my Uno or my Mega, I just click on it and I will have a board that I can just click into it or connect to it, should I say. So I can put my components here, make connections, and I'll be able to take this and put it straight onto my Arduino. It's pretty cool. That's not what we're going to do today. So we're going to start a new project. Just going to delete this. Oops. So we're going to do battery charger, LiPo. Just say battery, better. My spelling is horrible. There we go.
Powering off.
Ah, silly. Don't know why it keeps powering off.
Powering on.
So we're going to go.
We're
We're going to start with the schematic. So when you open a PCB, you have two files. You got your PCB and your schematic. You always start with the schematic, do all the connections, and then take it across to your PCB. So if you go File, set up my page. I always make it A3. It's nice big. That's just the size of the picture of the page. The date that I'm busy with. Let's say I like getting odd revision 1, battery charger, company, let's say Plumpot. Great, so we've got our schematic. You'll see at the bottom my battery charger, odd revision, the date, and then who did it. That's very nice just to keep track of everything. So what we're going to do today is make you know the batteries you normally buy at the hobby shop. I wonder if I can find. I think you guys use Amazon, but I'll just use one of the Dutch stuff. So a lot of times when you have a project, you'll have a battery like this that you buy to power your project while you're busy with, when you can't have it plugged into a wall or a USB. So we're going to build a single cell battery charging circuit and a PCB that we can plug this battery in, plug in a USB, and it will smart charge it. So that's the goal of today. I think most people are aware of these type of batteries. They actually come with a smart circuit inside of them. As you can see, that small strip there is actually a circuit of its own to protect it from short circuits, from under voltage. So when you have a LiPo battery, and you don't want to make it empty, totally empty, because then you can't recover it. So this makes sure that when it's just too low, it'll switch off to protect it. So let's get started. So first thing you have to do is have a chip or IC that will do this for us. So you have this goal now to charge your battery, but that goal needs some components to make that goal happen. So we're going to look for a chip or IC that will make life easier for us, so the brain behind the project. So I'm going to use the MCP, so this. So it's from Microchip. So the MCP 73831 is just, so a LiPo battery says 3.7, but fully charged is actually 4.2. So we're going to use this to charge our battery. So you can see that it got LED to tell you if it's charged, all the fun stuff. So we can view the data sheet. Don't worry too much about the detail, but as you can see, most data sheets will tell you how to make the circuit. So there you go. So they tell you connect your battery like that. Maybe have some of these capacitors. These are called decoupling capacitors. I'll explain more later on. You need a resistor for the LED. So this is your status LED. Your status LED is just going to say, is your battery charging or is it fully charged? So when this is fully charged, this chip is smart enough to say, I'm full, I don't need to charge anymore. And this is the program resistor. This resistor will just control the current to the battery, so how fast you want to charge the battery. So playing with this can make a big effect on how quickly your battery charges. And then there's some technical stuff, but I won't get into that. You have a goal and you find a chip to help you with that goal, and they give you the circuit. How easy can it be? But if you want to, we can go in more details, but not in the stream. How it works, why it works, all this fun stuff. But as you can see, so data sheet's the first place you go. So let's just keep this with us at the moment. So we're gonna do this circuit. That's gonna be our goal. I think in KiCad actually you can copy a picture over.
Auto shutdown initiated.
You cannot. Maybe let's try that. Because then I don't need to keep two things open. Place. So you can see. So this place name is quite important in schematic design. So you place things onto the schematic. So as you place symbol, board, wire, bus. These are most of the stuff we're going to use. So I just want to put an image because I want to put the schematic there. Why is everyone so quiet? So try putting background. You mean like music, Shinta? There's music playing, can you not hear it? Or do you want me to turn off the music? So there you guys can see. So I put this picture in my schematic so that I can have it when I design. If that makes sense. So this is going to be my base. Cool, so we've got this. So like I said, place is very important. So we can either push, I must turn off the music, no problem. Is that better? I think it's off now, right? Great, so thanks guys. So if you can't hear me or anything, please let me know. So we've got our circuit. Hey Arjun. Do you guys want the music off or on? I'm a bit confused now. Anyway, so we've got this. So like I said, we want to place a component. So this MCP373831 is known as a component. In your schematic, it's a symbol. So all these pictures are symbols. So I want to place a symbol on my schematic. Place symbol. So I can either go place symbol, or on my keyboard, I can just push A, and then all my symbol libraries will come up. Yours should not do this. It's doing a conflict between libraries. Great, so you can see here all my components in the KiCad libraries. So these are all default. So you can go on the internet. I'll speak about that later in maybe another video. You can go on the internet and download libraries from DigiKey and all those places. So you hardly ever need to make your own symbols, components, but you can, and we will. Not today, but we will. I think there's a video that Kerry did on YouTube about creating your own symbol. And I see we just lost connection. Try to keep both because the restream is giving issues again. Just want to get my chat thing correct. Oh, sorry. Okay, great. So you can see all the components we have, just different drivers, different LEDs, all that stuff. So this is all inside the KiCad libraries by default. You see oscillators. See Plumpot, we made a component before. So you won't have that in yours when you download KiCad. So let's see if they've got this MCP73831 in their own library. There we go. So they actually do. So you can see there, you just take the number, that's called the MPN, that's called your manufacturing part number. So every component in the world has a number that is linked to that component. So there we go. So you can see this. So SparkFun as a company, I think you guys know, they also have a library that we installed. I can send you guys the links if you want the library. But you can see there. So just be careful. The chip's MPN might be exactly the same, but there's sometimes numbers at the end of the chip that changes it a bit. So the family might be the same, but you can see here there's 2, 3, 4, 5 OT. So that is just the output voltage. The 234 is the output voltage that you can choose of the chip. So it's 4.2, 4.35. Because LiPos you can charge a bit over to 4.35 if you want as well. I think the life of the battery might decrease a bit, but I'm not too sure. But we're going to use the 4.2 volts one. I know it's safe. There we go. So there's our component. So you can see we've got the VBAT, same as the datasheet. We've got the VDD, same as the datasheet, stat, VSS. It's very important to make sure that the component that you have in KiCad, that the pinning numbers are the same as your datasheet. So you can see pin 2 here is VSS, pin 2 here is VSS. That's very important. Stat is 1, VDD is 4, VBAT is 3. So this and this correlates to one another. My ears are getting hot. So now we're going to try copy it sort of. So VDD is my power. So what I first do is I think about how the circuit what do I need to charge my battery? I've got this chip. How am I going to input my power and how am I going to charge my battery? So for the input, I'm going to use a USB, micro B, and then for the output, I need to have a connector, like a JST connector or something. We'll get there. Hey Ranesh, how you doing? So if we push A again for components, and I type in micro USB, there we go. So this USB, I'm not gonna use it for programming anything. So you can see D plus D minus, so that is the communication lines. We're not going to use it for that, we're only going to use it for charging. So we're only going to use the power, V bus and ground. Back to home now, where have you been? How's your birthday been? Getting old now. So now we've got our input. We've got the IC that's going to process the input, and then we need an output. So designs you do on a PCB, there's always going to be some input, some processing you do, and some output. That's just electronics engineering. That's basically what you do when you design something. Are you 21 now? How old are you? 21, still young. So we're going to look for connector. Guys, please, any questions, just shout, eh? If I'm going too fast, if I'm losing some of you. See, there, so we got our sorry. So I want my connector to show that way. So I'm gonna push X for flip. So X, you can see, flips it, and then R for rotate. Hey Ranesh, yeah. So I'm just showing the way of taking a schematic to a PCB. So we're just going to do a simple 1S battery charger because we can use it for the drone as well. But yes, that is what we're building today. And then later on we can add some stuff. But I just want the guys to get used to taking an idea and making it real. So we got our input, our processing, and our output. So now we get to the next step of the schematic is called the wires. So the wires are a way of connecting signals or components to each other. So if I push W for wire, you can see something pops up. So I'll go V bus, wire, no, that's a wire. So I need that, and I need my ground. So we need to give this V bus power, should I say. It's called a power source or a power port. So I'm going to say place power port, and you'll see I'll get a bunch of different ones. So for this, I'm going to say V bus. There we go. So V bus is just a terminology used for USB power. Yes. So this line is called V bus, but we'll get there now. And this is going to be my ground. Highlight, delete if you want to delete it. Ranesh, no, I've not. I've not heard about it. I'm going to put this here next to it. So you can see Vn is the voltage that's going to charge my battery, and we are going to charge it with this USB micro, and this is the power So this is actually output, right? So the USB gets plugged in and it supplies 5 volts to this V-bus line. So I'm going to take this, if I copy it, and I paste it here, it needs to be connected to my VDD, right? Because that's what it is, VN is connected to VDD. Because these names are the same, that means they are connected in real life. So it means that even if I took a wire, like this, all the way there, it's the same. So it's just the easier way to make sure the wires don't go all over the place, so you can connect it by names. So it's almost like Laura man. We can make it, but not today. Slowly but surely. It's a lot of power. Okay, so we've got our V-bus. You can see VSS is ground. I'll show you guys because this might actually look a bit different than this one because of how my pins are. So let's see. So in a schematic, you can see these small triangles. They are grounds. So mine looks mine looks the same. But sometimes I don't have to have it. You guys can see when I push here. So this here, this is what I push, place port power. Guys, if you can't see what I'm pushing and something's hiding it, please let me know. But you can say place power port. So sometimes the ground can look like that in schematics with the 3 lines or this triangle. So we've got that. So then my VDD goes, my VN goes to VDD pin 4. It goes to a LED with a resistor to my status. So let's push A for symbols. Yeah, I can hide the chat, but then if people on Twitch chat, then they can't see it, or you guys can't see what they say. But you guys can see what each other says on YouTube, right? Yeah, make the screen bigger. Yeah, we're restreaming on Twitch and YouTube. So we need a resistor and an LED. The direction of the LED is very important, so it goes down to ground. So you guys actually read it on YouTube itself, should I say? Okay, yeah. If someone chats on Twitch, I'll just read it out. Anyway, if you guys can't read it, it doesn't really matter. To move stuff, you just push M to move. So I've got my voltage that goes to an LED and it goes to VDD. So I've got a voltage, goes to LED and to VDD. Then we've got a resistor. And then push W for wire, and then goes to my stat. So you can see here they say 2 kilo ohm. 2 kilo ohm. So to do that, you just click on it, double click on it, and then your properties will come up, and there you can see value is 2K, so we just call it 2K. We'll get to the footprints later. Let's connect this. Shortly we're going to make it 0603, but we'll get there later. So I'm first going to, no, 0805 is too big. Hey Ashad, Bushali, I'm first going to make the schematic and then I'll add the footprints. You want to make it so big, Rashid? No. To solder, I guess. Or we can make it even a through hole if you want. But we'll get there. So we first do schematic, and then we can see what we want our package to look like, and then we choose our footprints. Because the resistor comes in many different footprints. Now you've got a point there. But we'll get there, Then we might as well make it 1206, but yeah. So let's have a look here. We've got the LED, we've got the resistor. So this is what's going to charge our battery. I'm thinking about taking this. Okay, I'm going to do this just to neaten up. So it's exactly the same. We'll say it's the same. I'll put it this side. So my VSS is going to be my ground. So I'll take this ground, copy it. They have the same name, so they are one. Oh shucks, this was supposed to go to stat. We missed it. No, that's fine. So the resistor goes to stat. Yes, I showed. No, 2K is fast enough. I've got 2K yet. I actually have 2K2 on my designs. We can look at the diagram later. Let's just stick to basics. So I've got my VBAT. So now I need another source for my battery. So I'm going to call this VBAT. So this and this are both power supplies, but they are not the same. Different names, different singles. Of course they do. In the Netherlands, anything goes. Okay, so I've got my battery. Now we need to program the speed of the charging. Copy this resistor. And this is, you see, this is wrong. So that resistor is to restrict the current for this LED. And this is way too high. The LED will be very, very not bright. I'm getting confused with the resistors. I think that's what you meant, right, Nish? Not the charging of the battery, but the LED won't be very bright. This must be 2K. No man, you guys have beards. I've seen a lot of Indian cricketers with beards. Or was it just moustaches? So this will charge the battery, the program resistor, will control the speed of the charge. Oh, no, the Netherlands is not like that. So now we're just missing these capacitors. So this is just a preference. You can put the capacitors like that in line, but I like to keep them separate. Just a preference, it's just nothing more than that. No, I do not like the capacitor. I just want to hide the, so we got 4.7 microfarad. Yeah, so 4.7 microfarad. And then I'm going to put V in, which is my V bus. To ground. So it's almost, it's exactly the same. So these are just decoupling capacitors to make sure my supply in is smooth. And then I need the same for the output. So I can highlight everything, copy, paste. But now this becomes VBAT. Highlight, delete, click on it, push C, and then we go. So that is the same as this. I hope that makes sense. So now we basically drew the same circuit as this. I don't think we're missing anything more. We got our USB power coming in. It has decoupling capacitors. So decoupling capacitors just to make sure that my supply in is stable, so it doesn't ripple. V-bus goes to my LED. I've got my 470 ohm resistor to limit the current for the LED, and then status, which will tell me what's the status of my battery. Great, so I have my VBAT. My VBAT's the single layer cell. So that's it. So we just made a first circuit according to datasheet. How easy was that? Our battery will be connected like this. So the battery connector always has 2 pins. You guys are too quiet. Am I losing you? You guys are you with me? Yeah, Ashad, you know all the stuff, eh? How's your projects going? How's your tokens, what do you call it, badges? You guys always talk. I like it, I like it. I'm fine. Cheer him up. I just don't want to go too fast and I'm lose people that want to learn. So please guys, I'm going too fast, just stop me. Who did you use? JL or PCB or the place in India that you told me about? Ota, what's Ota? Ota. So now I'm just going to neaten it up a bit. For this project, I think I'm going to make this page smaller. So page settings, A4. Okay, there we go. That's better. Ah. Oh, that'll be amazing. When is that? Isn't that's not already released? So what I'm going to do now is just put it, I like to put my designs in little boxes. So when I see the future, so at the bottom right here, I can make a box. Don't push escape too early. There we go, so I can place a text. So micro USB to supply charge. Always save, guys, don't do what I do, always save. Who did you send your PCBs to, Ashad? And then I'm going to do the same here. So here I'm going to say MCP 73831 battery charging circuit. Why are you typing in capitals all of a sudden, Anish? You're shouting at poor Ashad. There we go. So that's my circuit's charge. Yeah, it's frowned upon by some people. Maybe he's angry with you, Ashad. I don't know what you did. Maybe he's very upset with you. Battery connector. So we've got our input. Click and push C, you can copy it. Yeah, I saw on Instagram as well that he received something from JLPCB. He's busy with a new design, it seems. Output. Great. So, like I said earlier, in electronics and when you design, you always have inputs. You do something with the input and you have the output. That's the basics of any design. So that's the way you must start thinking. So I've got something I want to do, what I need to put in, what I need to process all the information to get that result that I want. So what I wanted is, I want my battery charged. How I'm going to do it? I need something to charge it with, my input. I need some smart circuit to charge the battery. So that is what we have now currently, right? So we've got our input, our process, and output. And I actually think that's all we need to charge a battery. So now you see that there's a lot of question marks here. J0, C, D. They are called designators. So they're called designators, and they represent the components. So for connectors, you'll have J. For ICs, you'll have U. For capacitors, C. Resistors R, LEDs D, connectors J. So for that is basically, You'll see when you get to the PCB, they'll have also designators. So my PCB will have D1 and my schematic will have D1, and that's how they link to, that's how they know where they are with respect to one another. So we don't type in every single one, so we don't go there, C1. On top left here, you'll have tools, annotate schematic, and say annotate. You'll see all of them updated. Perfect, eh? J1, C1, D1, R1, R2. So it will always annotate from left to right. So you'll see J1 here, and if we have another connector on the right, it'll be J2. I've got C1, C2. So always left to right. You can change it, but it's not important. 12 players. What will happen now? Will they still play, or are they gonna just kick those players out for 2 weeks? Or that's crazy. So now we're gonna put the footprint for the PCB on the schematic as well. So what we like to do is you click on it, double click, you get to the property page. Here you can see footprint. So footprint, push the button, and they're all open here. So we are looking for a USB connector. Oh, strange. USB. I normally use this micro B Molex. There's the part number if you want to buy it. Okay, so we can also put a data sheet, so let's do that. So this is actually the USB. See the number there, that's how it looks. So we take this, copy, put it there. Now we'll always have this component in our future designs, that if you want to see something, that'll be perfect. Got that. Now we have to do capacitors, footprint. So this is where the different footprints come from. So if you go on top here, you got capacitors, SMD and through hole. So the difference is SMD is soldered onto the PCB, there's no holes. So the components you put on a breadboard are called through holes, and that's TH2, but SMDs are just flat, so they're quite nice and small. So you can see 805, 1206, that is just the size. The bigger the number, the bigger the resistor. Or you can do through holes, that seems empty, that will be holes like that. This is what most people are used to. It's called axial, or radial. Okay, but we are going to use SMD. We're going to make it big. So I agree with Ranish, let's make it big so we can solder it easy. So I'm going to go even bigger than 0805, I'll go 1206. I'll make that, so you can see hand solder and just normal one. So the hand solder, they just made the pads a bit bigger so you can solder it easily. So let's do that. Now I'm going to copy this because I've got more resistors in my project. This one. I'm going to paste it. You guys will see how everything gets together later. You got LED, double click, or you can click on it, push E, symbol. E is also for properties. LED. Just use a 1206. SMD. So you can see the 1206, 603 are quite common names for footprints. Resistor, footprint. .1206 as well, hand soldered. So you can see resistors, capacitors actually look quite similar to each other, footprint wise. They are actually the same. And then we need a battery connector. So let's take a real life battery because we're going to have to plug it in. Where's that battery that I had earlier? Did I delete it? Sorry. So I'm going to use this as an example. So this got a JST connector. So we're going to try to find a female connector that will fit that. So if I go double click, footprint, connector, JST, it's a bit slow. I think those are 2 millimeters pitch or 1.5. 2 pin, there we go. Let's just make sure which one it is. I think it's 1.25. I don't know if it says. Those are pretty small. I think it's 1.25. So now we chose the 1.25. Now every single component has a footprint associated to it. So that's important. So I'm going to tell my program now of my KiCad that please take my schematic here and go put it on my PCB. To do this, I have to go Tools, Update PCB from Schematic. So we'll update my PCB from my schematic. So I push that. Now you'll see. I always just say reassociate, but it will tell you what it's going to do. It's going to add. Won't give me any errors or warnings. There we go. And now it's on my board. So this is the circuit we need to charge the battery. So now for the PCB we need to create a board outline. So we need the dimension of the PCB itself. So this can be quite small. So let's see how small we can make it. To do that, you have to go to Edge Cutouts on the right here. Edge Cutout is your layer that controls the board. And then we're going to draw a line, add graphics line. I keep in control to keep it straight. If you don't keep in control, it can go anywhere. So keep in control just to go straight. And now I want to make one line, and then I'm going to give a dimension 0. I want to try and make it small, 20. No, that's way too small. Let's see. Might be able to. Always make it bigger. I'm trying to see if I can fit it in. Okay, let's try 20 by 20. I think routing might be difficult the smaller we make it, but anyway. Control C, Control V. Just make sure they're all connected. So now we're going to have to try and get these components. So if I push Alt 3, I can check my 3D view. And now I want to try and get all those components on here. So I've got my USB. You can see there it says PCB edge. That is for you to try to tell you that please line that line up with the edge of the PCB. So you always want your micro USB to be off the edge a bit. So that's my input. So again, just like the schematic, we try to make the PCB board the same, right? So we have a process. So I've got my input, processing, output. So I've got my input, my processing will be in the middle, and then my output. I'll check this message. Spam. So I hope you guys are still with me. So input, output. Another important thing is if we got our, let's do this. You can see when I click on something here, it pops up here. So to show that it is linked. So it's a good indication to see if your components are linked properly. So if I click on this capacitor, it will tell me where it is. Yes. So let's do our processing. So we've got the LED. And you can see the names of the signals we give, VBAT, VBus. It's already part of our names here, you can see on the IC, which is great. So I've got my resistor, my LED goes to my resistor. So you see these white lines. These white lines are called rat nests, and they just show you where the wires are connected. So you can see R1 goes to my LED, which it does. So there it goes to pin 1, and it goes to the chip status. Yeah, so you can see there's another line on top that goes to my chip here. You can see it doesn't have any name, it doesn't have a status name. So the nets only get names when you give it names like ground or power, then they get names. Or I can push L for label and give it a name. So I'm going to give this name stat. Now it will have a name. So if I go back, tools, update, reassociate. Now stat will appear there. Just for interest sake. R2 needs to be, there's my R2, that's going to program and stat. Click on it, M to move. So you can see it goes to ground, which is pin 2, and it goes to pin 5, so it's perfect. And then I've got my decoupling capacitors. So decoupling capacitors, you want to be as close as possible to my IC. And then one more, and then we placed all. Great. I'll make the designators nice, so I'm going to just move this because I really want my capacitors as close as possible. So I'm going to move this up here, move this close to my battery and my IC. That's perfect. Push M to move, but we'll make it pretty later on. Let's just make sure it works. Yeah, it's fine, yeah. So now when we look at it, it kind of looks like we can do something with it. But so my USB does not have a 3D footprint, so we will give it a 3D footprint. So when we go to my component, we saved our data sheet, so we can just push a button and we can get there straight away, which is amazing. 3D view and download. CAD download, so it's called the CAD part. Generate CAD, add format. It's a step file, so we always want a step file. One more thing, a step file. Start generation. Another, I'll answer you now. It's a good question. You're talking about the decoupling capacitors, or why do I place everything so close? So yeah, the other ones are not that important. So to be honest, you can put this LED and resistor quite far from each other, far from chip, doesn't really matter. It's nicer to have it close because of routing, and when you have more components on the board, you would like your tracks to be shorter because you've got a lot of routing to do. So if you have components far from each other and you start routing, you're wasting space that you can route other components in. So it's space management. And then with the decoupling capacitors, that just always needs to be closer, because the closer it is, the shorter the tracks, shorter the impedance issues can be. So when you have a track, it is copper, and it can, if it's very long, it can have its own impedance as well, own resistance. So you don't want that neither. So you want your decoupling capacitors always as close as possible, close possible supply, if that makes sense. Help with losses and all that stuff, because what the decoupling capacitor is actually is if I have a 3.3 volts coming in, my capacitor actually just keeps a small charge, like a small battery. So when I lose that 3.3 volts, or it becomes 3.1 volts, my capacitor makes sure that it's 3.3 volts for a certain amount of time. Okay, the bigger capacitor, the bigger it is. So that's the idea. So it's just so if I've got a 3.3 volts and it fluctuates 3.1, 3.4, 3.5, I can have a constant 3.3 volts. Hey, electronics loop, how's it going? Thanks, man. Let's make it pretty now. Yeah, thanks. We're trying, eh? We're just trying. Like, same as you, right? You're just doing those YouTube videos to help the people understand. I keep missing them though. You haven't done a weekend one, right? Because you do it in the afternoons when I'm working. How's it going though? It's fun, right? Or, you know, guys, if you can, just go have a look at Electronics Loop's YouTube channel as well. He also gives live streams and tutorials about Arduinos and stuff. Very cool. Move, damn it. There we go. So I just want to make sure, so this yellow parts, light blue, I don't know what you want to call it, green, is the silk on the PCB. So if I push Alt 3, that is my designators. So when I solder it, I can see D1, R1. So when you solder it at home, you'll look at your schematic, you will be like R1 is 470. So I've got R1 here, I look at my PCB, R1, I put a 470 ohm there. But I was busy with this. Yes. So I downloaded the CAD, I think. Yes, so it is downloaded. I want to express it. So to add a step file, I just double click on it. 3D settings, open folder, and then I look where I saved it. So I just saved it in downloads now. Where's my downloads? Don't they show me downloads? I thought it'll be easier. Clearly not. Save it in a proper place. Don't do it like I just did because now I can't find it. Molex. Yeah, here's Molex stuff. Yeah, Molex step file. And now you should be able to see it. Good morning, Magpie. So now you can see it's not sitting how it would sit in real life, so you can click on it and then move up, rotate it, and I rotated the wrong way. Let's go back. Sorry guys. Stick it down, move it forward. It's a bit too much. Let's make it 1.2. You can type in here as well. It's just so I can give a realistic thing. How are you doing, Magpie? Will I be able to make one video in the future for basic electronics components? What do you mean by ALU design? I can make, if you ask, yeah, ALU design. You guys like speaking in acronyms. Okay. We can do that. That brings back memories. That's with flip-flops and gates and stuff. What do we know? Can we make the videos, or can you say that tutorial video for Eagle software? What I can do is I can download Eagle and see, because the principles are the same, right? So it's just the way around it is different. But yeah, I can look around on YouTube. I haven't actually seen any Eagle tutorials. I'm sure there's a lot. But let me download Eagle and I can have a look. Yeah, it's a good question I showed. Magpie is doing good. Trying to enjoy Sunday. Was not sure if I want to work on my circuit board projects today. You must do it. You must do it. I think we're almost done. I think probably be here for another half an hour or so. What you busy with on your circuit board? Magpie, sorry, but my chat between YouTube and Twitch is not going too well. So there's a lot of guys on YouTube chatting, and I can see your chat, but I don't think they can see it. So I don't know if you want to go to YouTube and join it there, or it doesn't matter. I'll just read out. So we added the USB connector. Thanks, Magpie. Pushali, yeah, for me it doesn't matter. Yeah, I enjoy KiCad. I've done KiCad. But what you can do, are you on our Discord? There's a lot of people on there that use Eagle as well, and maybe they can help you as well if you have questions with your projects. So if you go to the link below, I think there's our Discord channel. If you want to join there and ask questions about Eagle. I know that, what do I want to say now? My computer's bumming out. I know Ranish uses Eagle, so he might be able to help you. Okay, so we've got our so let's just add some silk on top to say what things are. So we go F, that's your front silk. It's normally your top silk, but in KiCad is your front silk. Take a text, we're going to type something here, we're going to say battery, yeah, let's just say bat. Yeah, so plus and minus, we can do that as well. Hey Magpie. Yeah, I can't read your name. What does that mean? Is it Greek or something? That is so cool. Make it smaller, it's a bit big. I think we're almost ready to root. That's a cool butterfly. R is for rotate. If you push Control and Enter, then we'll go to the next line, I think. No, it does not. Just push Enter. Hey, Dynasty. How are you doing? We are making a battery charging circuit. So about last week we finished our drone, and now we're going to make a charging circuit, just a simple charge. That's fine. Dynasty, I must just say that if you want, you can maybe go onto the YouTube side. There's guys chatting there. I'm having trouble with showing the chat of Twitch and YouTube together. I can read out what you say, of course, and I don't mind. But if you want to chat with the other guys and read what they're saying, maybe YouTube's better. Loving the questions, guys, loving the questions. So Dynasty Patel asked, he's a beginner design. What do you do once the design is complete? Do you send it to manufacturer, who source components, or what happens? Okay. So when you're done with this, we'll create files called Gerbers, and Gerbers is like your blueprint of the PCB. You'll send that to a manufacturer. I'll do it today as well, and then you will order it from the manufacturer. I'm going to take you through the whole process. Components, you can either ask them to do it for them. It's quite expensive, to be honest with you, For this, you can do it yourself. But Harshad actually showed me a nice tool for components that I've not played with yet. Maybe we should. That you can order your own components and then you can just solder it. But I'll take you through the whole process. So after I routed this, I'll generate the Gerbers, get the BOM file. It's called a BOM file, bill of materials, and then we'll send it to. I'll do a Gerber on Giles PCB, and maybe PCB way. Okay. So what must I call you now? Butterfly. No, I'm joking, Magpie. Okay, so Magpie, good question. That is correct. These components, it just depends on the guy who designed the footprint, to be honest with you. So rounded components are better for stencils. So when you make a footprint, we normally always make it a bit rounded. You never keep it square. That's a very good point. This one is square because someone made it and I just used it. But yeah, for hobby, for just making it home, it's really not that big difference. Yes, Asha, that's what I meant. It's who created it. So it's all about the creator. But with technology and stuff, it doesn't really make a big difference. Your design's not going to fail because of this. You can get technical, but loving the questions, guys. So now we're going to start routing. So to route, we got the top layer. You got your top of the PCB and bottom of the PCB, so this will be a 2-layer board. So we spoke about the rat nest, they tell you where to go. So now we can just go top and then we're going to route track. So now we're going to route the track. Just make sure you guys can see. Well, I'm on a full screen. So let's start. So once I click on it, you'll see it will tell me where to go. It will highlight. So all these can be connected. I should actually ground it. I'll ground it later. Yeah, when you go big volumes and things like that, sad face. That's quite cool. This, it looks like a sad face, but it's just the name. It's a T cut off, now it looks sad. Anyway, so like you can see, I always do my ground and voltages last. Yeah, routing emoji. Sometimes you'll start routing, and while you route, you'll see better opportunities. So just go with the flow. Just go with the flow. I always neaten up a bit later, so at the beginning I just try to get connector stuff, see where it takes me. I'm going to connect it to the bottom layer. I'll show you guys what I'm going to do. Oh shucks. So I like to throw copper cores on my boards. So I normally make the top layer my voltage and my bottom layer my ground. So to do that, I just click this button. It's called Add Fault Zones, and I just fill it. So that means this whole layer, let's make it VBus. Control to keep it straight. Now you'll see that we've got a copper pore of VBus. So Magpie says he always prefers a thin slice of solder mask between pads whenever possible, especially on tight pads. You're talking about here, in between. Yeah, I know what you mean. Just how to explain this. So solder mask is what you see here, the green part. So this whole board is, you get different layers. You get the copper inside, and then you get a solder mask on top. So the solder mask covering the copper. So what Magpie is trying to say is that he rather have a bigger opening here, so less solder mask, right? Is that what you're trying to say? Or do you want it smaller? Because there's a lot of designers that actually try to keep it open. Because the manufacturer, yeah, it's not something I really wanted to go into too much detail today, but you brought it up. So solder mask openings is where all the pads are. So pads are soldered. It's maybe easy if I go here. Yeah, it's mask. So if I click on the right here, you see F mask, that's top mask. So the pink is where the board is open and the copper is exposed. So if we click on this, I wonder if we can yeah, I don't want to get too complicated now. It's 0.4. Okay. We can look at the manufacturer specification when we do the Gerbers. I'm pretty sure they can do this. They've done it to me many times. Most manufacturers can do it. Yeah. I'll look at the specs when I do the Gerbers. I understand what you're trying to say. I just don't want to go too much detail with that now. I'm trying to keep it as much beginner as possible. Okay, this looks ugly. Now I'm going to put no. Save. Copper. I'm going to put a ground plane now. So the same that I did with the top. Make sure it covers the board. No, we'll get there. I just want to take it systematic, because the same thing happened last time. We started like this, and then we ended up making a drone. So, so let's just keep it simple. We'll definitely talk about it. It's very good points, because there's a lot about PCB design that, yeah, but we need to take it step by step. So now we've got a ground plane at the bottom of our board. So now we can actually take a via. So via is just like I like to call it a magic portal. It will just take my signal from the top layer to the bottom layer. So you can see I've got ground here. If I take ground and I just connect these to 100 mils. And I put a via and I go boom, somewhere there. Now it's connected to the bottom of the board where my ground, there, so it's connected there. Ground's fine now. So there's another ground, so we can just put a wire there and it's connected. V bus still needs to be connected, this ground still needs to be connected. So we can just that is bad. We don't want a component to be like that, and I don't want to wire underneath my thing. Might as well just connect it directly. Make a bit of cuts in the board, but it's fine. I'm going to ground the shield quick, so you can see this is actually the shield. So if I go back to my schematic, there you can see shield. So normally we ground earth the shields. So I just go tools, update again. I just like to reassociate, and there we go, now ground. Consider the board keep out, yes, so that is correct. So when you send it to JL or PCB or PCBWay, they'll actually come back to you and tell you to do that. And they can do it for you as well without you doing it. But yeah, I'll go through the specs when I order it. So it just means that when you have a board, you want your copper just to be inside the board, not over the whole board. What you can do is you can make keep out rules on the side here, and then you can throw as much copper as you want, and the keep out rule will keep it in for you. So normally a border outline, you'll make a keep out rule, because if you have voltages on the side as well, you don't want the voltage too close to the side. Things like that. But we'll get there in stream number 10. V-bus. You're telling me we don't need to go underneath this board at all? That's fine, I guess. So we can actually make this board a one-layer board if you really want to. So one layer means I just put all my signals on top. As you can see, I've got no green signals. So green signals is my bottom layer. I've got none of these. But I like 2 layers. So let's keep it 2 layers. It doesn't affect the cost that much. We'll see how much it affects the cost. Let's see how much it affects the cost. So we kind of have most of it connected, or everything connected. You can see here, Magpie automatically does it. There's a setting in KiCad. I'm not exactly sure where. Maybe my copper board itself. Yeah, clearance, there we go. So it automatically makes a clearance, which is cool. So distance between things are called clearances. So now to check that we actually got everything connected. So we had our schematic. Like I said, this is very important schematic because your PCB will just check, okay, what did I connect here? And do I match what you have here? So if your mistake is here, you will take it across without knowing. So this is very important. So once we have our PCB, we say tools, inspect, design, rule check. So this will make sure that all my things are connected, there's no overlapping of components, things like that. There's a lot of rules you can alter, but I'm not going to do that now. I'll talk about track width and stuff on a later day. So we say run DRC. I just want to refill my copper pores. There's no unconnected items and there's no problems. So this board is according to schematic. But like I said, if your schematic is incorrect, then it's not to say your PCB will correct. But this PCB is identical to the schematic, which is what we want. So there we go. So you're going to plug in your battery, you're going to plug in your USB, and this will charge. Magpie, yes. But we are trying to. So we did it with the drone. So our drones decoupling capacitors doesn't look like this, but we are just taking from the data sheet. I've got an idea from the data sheet, how can I bring it to life? So that's the point of the string. So they suggest this. I do agree with you about the capacitors. We have them in our drone that we did because we use the same charges. But yeah, let's just keep it to the schematic. How do I take a schematic to a PCB? There's a lot of people who just want to know how the PCB design works, the process, and then later on we'll get more advanced. It is better for EMC, but this will still work for hobby, just to charge. Guys, we'll talk about EMC designs later on. So yeah, we've got this. So now we want to order this. Let's just make sure that everything looks fine. So we've got USB pads. I can see all my designators, except this one is not with C1. So let's move C1. Magpie, are you on our Discord? I think you should join our Discord. There's a lot of people on there as well that also knows a lot about electronics. It'd be quite nice to chat and talk about everything. Hey, hello. It's a good question. So what you guys don't know, a breadboard is just where you can put in your components. I don't know one lying around here, and to simulate the design that you want to take to the PCB. So I would always first do your design on a PCB, on a breadboard before taking to PCB. It takes the risk out of it. But now he's asking, must you take it to a variable board as well? So variable board is your piece of a proto PCB where you can solder it like a breadboard, but you solder it and you can connect things like that. How complicated is your design? Is it working on breadboard? I would say if it's working on the breadboard and you have written down the schematic and things, I'll go straight to PCB. Just thinking what advantage you'll have now going from a breadboard to a variable. I would just go to a variable if you want to, if you would like to put in housing or something and build a prototype like that, then a variable is better because it's soldered so the wires are more stable than breadboard. Then I would go to a variable if you want to build it into a physical housing. But if it's just on your desk and you want to put a PCB in housing, I would just do a PCB. What are you busy making, if we may ask? It's just my opinion, eh? So I don't know what other people think, but I think you are ready. If it's working, just go straight to a PCB. Let's have a look. And it's always nice as well to make sure that your silk is either on copper or off copper. So when you have the silk that's sometimes half on copper, half on silk, they don't look the same. They change color a bit. It's not the end of the world. It's just nice to. So on the left hand side here, you can actually click and you can see where everything is. These are all preferences, eh? So every designer, every engineer has his own preference. This is ugly, I don't like that. Wow, that sounds cool. So Anil is busy designing an electronic device to non-intrusive measures to level of beer in a keg in real time. If no one has made those sensors from KiCad Studio, it won't be available and you'll have to make it yourself. I can show you guys how to do that. It's not difficult. It just takes time if you have a lot of sensors. That sounds like a very cool project. Non-intrusive measure. So you're not going to open the keg? That's for sure. Can you not do it by weight? So if you measure the weight goes down? Or yeah, I'm interested to know. Is it a startup? Are you allowed to tell us? And now, are you part of our Discord? Join our Discord. I would love to see this project. I'm sure the community will also love to see it. Resonant with audio. That sounds amazing. Why can't you do it with weight? Or can you do it with weight? You must send us a picture when it's done. Yeah, but it's a very cool concept. I think you got to volunteer for testing. Okay, so you're looking for a more elegant, stable solution. Understood. Let's just do one more design rule check. Oh, welcome. I'm glad you're here. So, are you a software engineer or are you still studying? Have you done PCBs before? Do you want to learn how to make PCBs for this project, or what brought you here? Come on, man. Okay, I think we are ready. We'll get there later, but this pour is not very ideal. But well, that's gonna all work. Nice, man. Yeah, I would say use KiCad, but it's just my preference. But you can use Eagle as well. If you want free ones, there's nice software like Altium and stuff, but it's very expensive. Guys, so we just finished our design from datasheet. So we got our datasheet, we had the goal of charging a battery, and we found a solution how to charge a battery. So now we want to order it. So to do that, we need to generate files called Gerbers. So Gerbers are, like I said, a blueprint. You give it to the manufacturer and they can make your PCB. To do that, you have to use the plot function. So here you can say plot. I'm not going to go into too much detail for this now, but you can kind of just keep it as it is. You can keep the choices. So there's my layers, my paste. So all this stuff. So don't worry too much about that now. We'll go there later. Now you still need to generate the drill holes. So the drill holes is a file just to say where to drill my holes, like the name says. Generate. Don't worry about too much. Just say generate drill files. And I'll say plot. Now these files are created where your project's stored. So current projects, battery charger. So yeah, my things are stored. So you can see there, generate drill holes, generate Gerbers. So then I just go right click, send to unzip it. And I say battery charger, take away the back. Undo. You can name it anything actually. And this folder I will give to my manufacturer. Circuit maker. Is circuit maker free? Yeah, I also used Altium for 5 years. I love Altium. Yeah, it's free. But circuit maker is online, right? It's cloud based. Yeah, Altium is just a bit expensive for a person. Great, so we've got our PDF, a zip file of Gerbers. So now let's see if we can order some. So there's two companies that I normally use. So if I just want quick PCBs, I normally use Gerbers PCB. But if I want a company to populate it for me, I use PCB Way. So then I'll send them the files and they'll make the PCB with the components, everything for me. So if you go here, let me just sign in. It's taking forever. I almost had another robot. When you guys think they'll use a camera to see that we're not robots? So then you can go quote now. And you just add your Gerbers. Easy as that. So we just create a zip file. So we created the zip file, battery charger, we just open it. And there we go. You can actually see they make like a nice little picture. It's 20 by 20, give you the size of 5. And there's all the stuff, we'll worry about that later. And then yeah, it's $2 for 5 of them. But the shipping's expensive. And then you would just go save an order, and then you'll have your PCB in about, I think, a week. That's how easy it is to order a PCB. How cool is that? But now we need to be able to order the components because we're going to solder ourselves. So it's a small PCB, so components wise can be easy. You can go file, not here, it's on the PCB side, fabricate outputs, and you get a BOM file. Now this will carry Excel. So you can see this file will generate J1 is a USB, U2 is my MCP3. So you can use this to order your components. You can send it to a company like PCB Way and they will do it for you. So yeah, that's exactly how you order it. Then you'll just search for this, buy it on Amazon or wherever you guys buy your chips. But that is how easy it was. Is there any questions? I will order this board, so then I'll solder it and put it together, show that it works. All these files are available, so if you guys in our Discord channel, our GitHub link is there, everything's saved there, all open source, all free. But yeah, that is basically it. So we had an idea of what we want to do. We wanted to charge a battery. We decided the process, how we're going to charge it, our input we needed, found a data sheet to help us, the chip, and then we took this idea and just made a PCB. If it's a complex board, I've got a reflow oven at home, but if it's like this, I'll solder by hand. So if it's a board with a lot of components, then I'll order stencil and things like that. But that will be on video number 7. And yourself, what projects are you busy with? Magpie? Guys, I think we are done now with this design. I'm gonna make shorter highlights. So because there's a lot of chatting in between, right? So if you want to rewatch it, I'm gonna snippet it together, so it's just the explanation of the whole process. So I will do that and put it on YouTube as well. I don't know, actually. I've never ordered a stencil from PCBWay. Oh, I have, but not to get myself, so they do it. I order my stencil from JL PCB, so if you go here, stencil at the bottom, then a stencil is about $7. Shinta, so after this is done, YouTube automatically updates the live to YouTube. So this will always be on YouTube, this whole session if you want to rewatch it. But I'm going to try and make it shorter and more precise for the people who don't want to watch everything. But I would, if you guys can download KiCad, we can do stuff together as well. Be quite nice. Making a clock. That sounds cool. That sounds very cool. Are you almost done, or have you pulled up a mock-up? You're welcome, Chinta. You're welcome. But I think that's that, guys. I'm just thinking what more we can. I don't want to get too advanced, so next week we'll go one step further. So each week we'll just add a little bit. So I'm going to try to go slow, so we can all be. At the end of the year, we're all on the same page. Then we can start making nice stuff. I will order this. Maybe we'll add another charger, see what we can do. If you guys can think of projects that you would like to do, we can also do it on a live stream. But let's not get too complicated at the moment. Let's keep it simple. Guys, if you want, you can join our Discord channel where we chat during the week about stuff and people share their projects, help each other. So it's pretty cool. So if you want to be part of that, just join us. It's really fun. A lot of cool people. A lot of people to help each other. So that's basically it. We're creating a community where we can help each other. You can. If you can just do it on the... what do you call it? There's a general chat, and then there is a community projects. So if you can just paste it in the community project, that's fine. So not too much stuff in the general, because then it's going to get too much. But if you post on community chat, that's perfect, man. I can see we've got a drone channel as well, because the drone thing just took off. So we never know if something takes off, we'll make a channel for it. So yeah. Yes, community projects. There's really it's becoming a nice community. There's a lot of nice people from around the world, and they just want to build stuff, make stuff, help each other. So it's nice. It's very cool. I'm very happy with it. So that's that, I think, guys. I hope you guys enjoyed it. Is there any more questions that you guys would like to know before we close off? So I'll do this every every Sunday, sorry. Every Sunday. I hope you guys have a great week. You can always ask me questions on Instagram or Discord, whatever. Always willing to help and answer. And if I don't know the answers, there's people on Discord who will know the answers. Hey Andrew. Yeah, but I'll put the highlights reel. It's 12 o'clock your time every Sunday. How are you doing? Are you on the farm? So just for you, we just made a simple how to get from an idea to a project. So we wanted to charge a battery, we found a chip, we looked at the data sheet how we should connect it. We basically just copied it. So there are ways to make this better for EMC, all that stuff, but we'll get there later. Just keep it simple. Spoke about inputs, output, and the process we want to follow. Took it to a board, and then showed the guys how to order it from a company. So that's what we did today. So I think that's that. Guys, if you have no other questions, then I will call it a day and then catch you guys on Discord. Cool, guys. Have a good day, have a good week. Awesome, Andrew. I'm going to make a highlight reel as well, but that probably won't be done. It takes a while, so it'll probably be only tonight. But guys, thanks a lot for watching, and thanks for participating. I like the conversation we're having. Thanks, Magpie. Thanks for your help as well. I like having some experienced guys like you as well, because I can miss a lot. I'm not perfect. So the more we can help the guys, the better. But yeah, guys, thanks. Thanks for keeping me company. Have a good week. Have a good day. Enjoy the PCB designs. Catch you guys on Discord. It's on the link below. Eh? So just click on it, follow the steps, and just thumbs up the rules. Because if you don't thumbs up the rules, you can't communicate on the channel. So that's important. It's just so that you read the rules. We're all nice people. Don't be jerks. Yeah, cool, guys. Till next time, next Sunday, same time, same place.